Managing Director of Silicon Valley Robotics, which is the industry group for the largest robotics cluster of companies and research groups in the world. How cool is that? I love my job. But robots? When I was a little girl, I just wanted to be an astronaut. We go back a couple of slides, right? I wanted to explore other planets. I wanted to be the first person to meet aliens. Although I was already a little concerned that while I was the older, smarter one, my brother had the pilot hat. But I was excited by technology. I stayed off school to watch the moon landing. I had pin-ups of Gemini and Apollo capsules. I built a lunar landing module. I built a kick-ass Dalek costume. I loved science fiction, Asimov, Clarke, Heinlein. And I still love science fiction. But science fiction set really high expectations. Our imaginations can travel at warp speed, and reality hasn't kept pace. In reality, I still haven't gone to space, and I still don't have a robot maid, like Rosie from the Jetsons. And from where I sit in Silicon Valley Robotics, Rosie is still a way off. And this is after more than 50 years of robot development. In fact, robots have been around longer than I have. The first industrial robot arm was installed in General Motors the year I was born. At the end of the 20th century, there was still only a handful of humanoids and maybe 1 million industrial robot arms out there. But the pace of change is accelerating to something like, well, beam me up, Scotty. In the last 10 years, we now have hundreds of humanoids out there. We have more than 2 million industrial robot arms operating in the world today. Japan, the US, Germany, Korea, but it's actually China that is buying more robots than the rest of the world put together and will become the dominant nation in robotics in the next couple of years. 10 years ago, we didn't have a consumer robotics market. But sales of things like small drones have really taken off, with more than 3 million sold since 2007, probably more like 5 million now. And we say that robot vacuum cleaners are the most widely distributed robots in the world, with iRobot alone shipping more than 10 million. But really, it's our cars and planes and trains that are the most widely distributed robots in the world, not the fully autonomous vehicles of the future. But our robot systems, but our cars, planes, and trains today are just as much robots as these other devices. We don't call them robots, though, we call them cars. And it makes me really curious to know what is coming next out of the robotics research labs. Now, did I say I love my job? I have the advanced highlights from ICRA, the International Conference on Robotics and Automation, that will be held in the next couple of weeks. And it's showing things like component technologies, sensors, and actuators that can go together in some pretty cool systems, like this exoskeleton that can stand on its own. Now, this is one of the perks of being a robotics researcher, is you get to beat your robots up. Now, I mentioned cars, planes, and trains. This is a hand-launched solar-powered vehicle, and it's one of many new vehicles being designed. This little copter uses only 2 motors to control thrust, pitch, roll, and yaw. These quadcopters are inherently safe and can survive collisions in the environment, which opens up a whole range of new uses for drones. These snake-like robots can be used in industry and in surgery. There is a pretty obvious application for this multi-robot system, but most research robotics is still many years off the application, and some things are so novel, it's hard to even imagine how they're going to be used. But magnetically guided microbots are currently in clinical trials for eye surgery and can potentially revolutionize construction and manufacturing. But it's not just robotics that benefits from robotics research. Advances in artificial intelligence, machine learning, and computer vision are all coming from robotics research. But for robots, it's absolutely critical that they know how to navigate better in the world and that they understand the objects that are around them. Not just the objects themselves, but how to orient themselves in relation to objects. Robots need to learn their own constraints and limitations. For example, you don't want your solar-powered rover driving into the shadows. Simulation is playing an important role in the development of robust robotic systems. Some robots can travel faster than humans, even Usain Bolt. But generally speaking, they stumble over difficult terrain and have difficulty with a dynamic environment. And that's really not good enough for operating in a human environment. With this slow speed and this much uncertainty and movement, we expect more for interactions in the real world. Now, you notice how slow this is? Most research videos have been sped up. Always look for the 6 times, 12 times, 20 times. This is the world's most sophisticated robot taking 1 minute to fold a chair. These guys take 3 minutes to complete this task. But it's still exciting because they're showing communication and collaboration, both on independent and on cooperative tasks. And that's leading the way for the new range of collaborative robots that can work safely with humans. Robots that are capable of perception of humans in their environment and of protective actions. And beyond that, robots that are capable of being trained and learning tasks in a more simple fashion. As well as learning better, robots are also becoming easier to program. But one of the things that most excites me about the upcoming ICRA conference is that the organizing committee is an all-female committee. That's 51 roboticists, 51 women roboticists, whereas in previous years there have only been 1 or 2 women on any of the conference committees. So things are evolving. But by now it should be clear that the evolution of robots is not a case of better than human. It's a case of very, very different to human. It's a case of something almost alien. And yet we keep trying to build humanoid robots. We seem to be missing a slide, but it's a description of the evolution of humanoid robots to Asimo, which we considered the peak of humanoid robots. And I have to say, the problem is that after all the years spent developing Asimo, when the Fukushima disaster happened, there were no robots that were capable of going into the nuclear reactor and performing a couple of simple tasks that would have prevented the meltdown. So the latest DARPA Grand Challenge is for the development of humanoid robots capable of performing a set of disaster response tasks. 17 teams competed in the DRC trials at the end of 2013, $3.5 million of prize money and many more millions of dollars of funding. These robots were attempting to perform 8 simple disaster response tasks. We'll move on. This is Valkyrie from NASA. Was unfortunately not able to win any points on any of the tasks. Many of the teams were unable to perform. This is Shaft, who was able to both push a door open and pull a door, winning 27 points out of 32 possible points. Shaft won the trials. Shaft cleared their opposition just as successfully as they cleared the rubble in this task, and were then acquired by Google. Google also acquired Boston Dynamics, who built the Atlas robot, which was used by 7 other teams. This click is crazy. Some of the robots aren't that humanoid to look at. This is Chimp from CMU, which is more of a quadruped than a biped, but it makes it more stable on irregular terrain. And this is Atlas, drilling a hole in the wall with a power tool. And despite the resemblances that you might see to the robot from the film Chappie, This iteration of Atlas was not at all agile and needed an expensive infrastructure for support and power. Most of the teams did not even attempt the driver car task. It was simply too difficult for them. 18 months later, DARPA has raised the bar. In the trials, teams had 1 hour to attempt each task, and they were able to assist their robots in between each task. In the finals, which will be held in just a few weeks, the teams are only going to have 1 hour to complete all of the tasks, and they will not be able to assist their robot. But already some teams have produced videos demonstrating their robots performing tasks. This is from Team Keist from Korea. And did I mention that DARPA have made it harder? This time, the robots will not be tethered, and they will have to carry their own power supply. We're seeing the state of art of robotics emerging from research labs and into the real world. Rosie is getting closer. It's no surprise because DARPA's last grand challenge brought us autonomous cars. In 2004, none of the teams could complete the desert drive, but by 2007, all of the teams were completing simulated urban environment driving. Google bought the winning teams, and by 2011, autonomous cars were driving on the 101 freeway in San Francisco. We're about to see a family of service robots entering our lives. Pepper from Aldebaran is already selling mobile phones in SoftBank stores in Japan. Who could resist that face? Savioke's robot butler has successfully delivered more than 2,000 items and is ready for deployment. Jibo from social robotics pioneer Cynthia Brazil was one of the most successful crowdfunding campaigns ever. Fellow robots, Oshbot, is showing customers and store associates where to find the right nuts and bolts in Orchard Supply hardware stores. Baxter is out of the protective cage and working alongside people on the factory line. And just launched last week a new logistics robot, Fetch. Fetch is designed specifically to work in warehouses for pick and pack. And you probably noticed Fetch is a spin-off of that uber-sophisticated research robot, the PR2. But where a PR2 cost $400,000, Fetch is maybe a tenth of that price and works alongside its mobile autonomous base companion, can work in combination of units and alongside people. Because we keep ordering things online and we expect them to be delivered to our doorstep, but people don't enjoy warehouse work. So it's just as well we're building robots that can do something useful, like Fetch. Our imaginations still travel at the speed of science fiction, but we're entering a warp drive moment. Did I say I love my job? I get to see science fiction becoming reality every day. Thank you.